broadcast for this. And that should be working now fine. So, there we go. It should totally work now. And let's see how that is. I think I'm getting a much better sound happening. Can you check, let's see if you can check YouTube now. That should work. Okay. Nope, still not. Well, it's going to take a second. Check it now, Shahid. It should be working just fine now as you should be able to hear that now. Okay, good. All right, so awesome. Thank you for that feedback. So like I said, all I've done so far, I really just added the just to go back for because you couldn't hear me earlier. Under navigation, I added in the tile comparator, and we needed this tile comparator because without the tile comparator, you can't do the min heap that we're going to create, which is the priority queue. That's what we had. And then what we also did just earlier for the people who were trying to watch online and stuff is we changed the obstacles array to an obstacles vector, and now we're going to go into our build obstacles method, and then we're going to go from I, where I is less than 300. Now this is kind of like hard-coded, and I don't like to do this typically, but we're going to start with this. So we're going to say m_p obstacles. That is, we're going to push back a new obstacle. So all we're doing here is we're initializing the obstacles vector with actual objects in it. So we're preloading 300 obstacles. Okay, that's what we're doing. And the good thing about this is we can just reset them or do whatever we want. We can put them on the screen and take them off the screen whenever we feel like it. So that's the first part. Save. And so again, what we're doing here is we're just putting together an obstacle list, kind of components that are here that are going to help us, okay? The obstacle list. I also want to, if we're going to put obstacles on the scene on the screen at the same time, I want some obstacle utility functions that I want to use. And one of them is a void m_remove obstacle at, and I'm going to pass in a column and a row. Okay, that's what I want to do. I'm also going to void m_remove obstacle at, but in this case, I'm going to have a variant of the function, or an overloaded version of the function, which is glm vec2, which is the grid position. Okay, that's what I'm going to do there. And as well, remove all obstacles is what I want there as well. So those are the other functions that I want. Remove all obstacles. And these three functions are going to help us when we place obstacles in the scene. Okay, so again, going up to here, going to place scene, just going to add in, generate definitions by declarations, those three, two versions of the same one, so two different versions, plus remove all obstacles, press finish. And so now what I want to do is, let's think about the first version. So remove obstacle at row and column, or column and row. So I want to say for, and I want to do a for each, and a for each m_p obstacles, m_p obstacles. That's what I want to do. And we're going to say for every obstacle in obstacles, and let's use the ampersand here, for every auto ampersand, which means reference or obstacle within obstacles, if my obstacle is not equal to null pointer, we want to make sure that's not equal to null pointer, then what I want to do is I want to static cast, and I want to cast the obstacle get grid position.x, right? If that is equal to the column, and at the same time, if my static cast int obstacle get grid position.y is equal to row. If both of those things are true, this is kind of a way of us searching through the obstacle list to find the right thing. Then what do I want to do? I want to remove child, the obstacle, That's what I want to remove from the scene. And then I'm going to say m_p obstacles. And I'm going to use that funky syntax that we had before, which is the way we make it so that a single dimensional array is like acting like a multi-dimensional array is we're going to index it like this. We're going to say row times config column num, and then we're going to add in the column. So this is a way of indexing the object. That's going to equal to a new obstacle. So that's going to be the thing we're going to do. So we're going to replace the one we removed with an empty one. That's what's going to happen. Okay. All right. So that is remove obstacle at, and we can make these const. We can make this one also const as per our resharper. And then this other one, which is the exact same name, remove obstacle at. This is also remove obstacle at, but we're going to use a grid position instead of column and row. This is an alternative for the user. So we're going to say emp_remove obstacle at. There we go. And then we're going to say static cast and then int, and we're going to cast the grid position dot x. And then we're also going to do a static cast int, and we're going to have the grid position dot y is something that we're going to pass over from this function variant to this one. That's what's happening. We're just passing it through, and we can make this const. So this way we can put in either column and row or a vec2 grid position, and that'll be good. That'll be good. Yes, that's the only thing we've done so far. Remove obstacle. Remove obstacle at. Then there's also remove obstacles. I want to remove them all. And sometimes we need to do this when we reset. So we're going to say for each. And we're going to say for each m_p obstacles. For every obstacle in obstacles. Obstacle. And again, we'll do the same thing. Auto ampersand. And we'll say, let's remove all those. Remove child. And we'll say that obstacle is removed. Excellent. And then we'll say m_p obstacles we will clear. So this is going to clear that up. So when we remove the obstacles, we also clear up the obstacle array. We can do an auto const there too. And that is remove obstacles. So we kind of have those three utility functions for the obstacles. Let's put this up on GitHub. I think this is a great place to do that. So, okay, so let's just do git add dot, git commit -m, and we'll say added obstacle functions. There we go. All right, so that is good, and let's continue. So that is up to here. That's where we kind of went through and we changed the obstacle to a list, a vector. We made build obstacles where we built them. We also remove obstacle at, both of those two things, and remove all obstacles. That's what we've done so far. And we did this because we want to be able to add obstacles more. Yeah, it's recorded, Curtis. The link for this is actually live right now. If you want to see it live, you can always go and watch it. Here it is. So yeah. So what we want to do is continue with this thing, and so we've added these obstacles in there, and we have these we're going to deal with in a bit. But I want to build up our map, and one thing we also want to do is we had a funky little template that we used last week. And this template was called add navigation object to grid. We don't want to just add navigation object to grid. Let's rename this template. So we're going to go refactor rename. And let's rename this thing to m_add object to grid. Add object to grid is what it should be. So add object to grid. There we go. And add object to grid, what it's going to do is, if you remember what it did last time, let's go there. So go to definition, go to. Last time we made it work so that it would return something. It returned a template pointer. we want to make it, we want to change this to make it void. So please do that. Okay, make it void. And if I go back to the placing, then we can see that this should also be void here. So just a couple of changes. So this is void. And we don't have to return an object anymore. Okay. And this could be a const expression. That's what this will turn into, a const expression. So far, so good. And where we have our errors now, which is inside of our, first of all, there's no mark impassable anymore. We don't have that in our start method. And you can remove these parts. So you don't have to have, you don't have to return anything. Okay. And what we want to do to fix that, to make it work, because it wouldn't work without making some changes, in our definition for add object to grid, we just want to add in an ampersand here. So there is a difference. Why are we adding this in? Because basically, if we just pass in t star, that's the type pointer. But we don't just want to access the type pointer, but a reference to that as well. I know it's a tricky little syntax, but that's what it is. So t star ampersand is what the right thing to do is. And if I go back to placing, we also must make that exactly what that looks like. T star ampersand here inside of our add object to grid. And now it's looking pretty good. So add object to grid. And again, what this is going to help us do is if I want to add those funky little parts in there. And just to talk about what this does really quickly again, we add the t-type, like we said, object, whatever that is, whether it's a ship or a whether it's a impassable tile or something else, we add it to the grid. So we add it to the scene. That's what this is doing, right? And we're going to do this by instantiate an object of type T. Okay, that's what we're doing. Okay, that's how we're doing it. And then we're going to, down here, we're going to record the grid space position. That's what we're doing there. Okay, so everything else is the exact same. I just want to mention these things that we're doing here with our underscore add object to grid. Okay. Okay, wonderful. I want to get back to the placing.h and I want to add another function like that, another function template. And this one is going to be a different type. So I'm going to say template type name t. And I'm going to say void m underscore. We're going to call this move game object. Move game object. It's going to be the same t star ampersand, whatever that object is. And we're going to move it according to the row and column where we want it to go. And we're going to also pass in the tile status. Okay, so that is our little move game object. And we're going to use this to replace the stuff. Yep, I'll get there in a second, Roger. I'm going to use this to replace the, the stuff that's in the UI function. So I'm going to copy this right here. And I'm going to go back to my place scene exactly where this was. And I'm just going to kind of populate this one in there. And I'm going to just change the starting of this function so it says placing. Okay, you have to do that manually for some of these. ReSharper won't do it for you. So this is kind of what it's going to look like. Okay. And Roger was asking for the remove all obstacles. We're just going to go there really quickly. Here it is. Remove all obstacles. Just a for each loop. A range for loop that's removing a child, which is the obstacle, and it's clearing the obstacles up. Okay. Wow. All right, so back to this. So I want to be able to move my game object, and we do moving game object right now. Where we do it is inside the GUI function. Let me take a look at that and see what I'm talking about. So we actually do this, but we do it badly. And where we do it, if you look, let's just change the name of the lab to lab 5 here on 109. Change to lab 5. And if I scroll down, notice that there, when we move our starship, we do this work. And it's identical to this work for the most part, except for the compute tile cost thing. So I want to be able to do this in a little function, which is going to help us. All right. So I want to grab this, copy it, this part. This is in the IMGUI function. I'm going to copy this part. And then I'm going to skip back to that little move function, which is a template. Okay. So here it is. And inside there, what I want to do is I want to kind of paste that in. So this is what it looks like. Okay. I need a reference to the offset. So here's the offset reference. We're going to put that in here. And then we can start replacing object for starship. So take object and replace wherever it says starship in here. So this is where we replace all that. And I'm just going to make this on one line now so you can see it. So object for starship, I just replaced starship with object because it's more generic this way as opposed to what we had earlier. And anywhere where it says start position 0 and start position 1 with column and row. So I'm just going to go here and go column. And this one is going to be row. And the same thing here, column and row. All right, so that is a generic version of the object that the kind of the move function we had already in IMGUI when we move an object, but now it can apply to either starship or our target or something else in the future. Okay, that's what we want to do. And what I want to do here is I want to talk about some other things that can happen. So yes, we're going to convert stuff, but what I want to do is not only the first part here, let me just talk about this. So this first part, oh, there's one more part we have to change right now, which is this part. But I'll explain it. This should be down here. This should change to status. So instead of like a start, that'll be different for the goal. The goal will be goal. The start will be start. Whatever is going to be the status that you pass in here. Okay. So the way this works right now is I'm going to get the tile where the object is positioned in the grid, and I'm going to set the tile status when we move it to unvisited, except when, and this is a bit of the glitch that we're experiencing, if I pass over the the obstacle tiles with my starship or my target, I don't want them to change. So in this way, we're going to check to see if that's what's happening. So we're going to say if m underscore get tile, and we're going to pass in the object and get grid position, okay? And we're going to say that if the get tile status, if that's kind of not equal to impassable, if it's not equal to impassable, then and only then do we want to be able to change the tile we're moving to. This is the tile. Sorry, this is the tile we're moving from. This tile we're moving from to unvisited. So if we're already sitting inside of the by any chance if we're on top of or we're blocking out an impassable tile, we want to not change it. We want to leave it as impassable. Okay, that's why we're doing this. Likely, like the same token, if we're going the other way, so down in here, right? And I'm going to do the same check. If it's not the impassable tile, I'm going to put that in there, then and only then do I want to change this tile status to the new tile I'm moving to. This is where I'm going to. So it's kind of coming from. So only change status of tile object is moving from if it is not an impassable tile. So if you pass over this, you'll see it later on, it'll cause a bit of a glitch. We're going to fix that here. And the same thing, only change the status of tile object is moving to if it is not an impassable tile. Okay, so that's the only time I want to change those two things. Okay, and that's why we're repeating it twice, but it's happening at different times. So we're moving it from here, and then what we're doing is as soon as we move to the old position, we transform. We move the transform to the new tile row, and we set the grid position to that new place. And as soon as we set the grid position to that new place, then what we want to do is we want to reset the tile status to match whatever this is, which would be like the start or the goal or something else. Okay, so here what I want to do is I just want to make this const because that's going to be changed. Okay, and that's where we're at with that. we know whenever we set grid position that row and column grid position is something that is going to be a float, and we want to convert it to a float for set grid position. So let's do that. So we'll say static class, and it'll be float here, and a static cast, and it'll be float here. That's just because the type that set grid position is expecting is a floating point type. Okay. And that should be a good start. We're going to come back to this later on. One thing is for column and row, we're also going to make these const. Awesome. Okay, so that is the new m_move game object method. And now I want to use this thing. The method is going to be used where we had imGUI work. So let's go back to imGUI. So that's the GUI function. And down in here where we're removing our starship, or we're removing our goal, our target, we can replace this stuff with that new function. So let me show you how this works. So it's going to look like this: m_move game object. We need a record. What game object are we moving? m_p starship. We're moving that one. And where are we moving it to? Well, we want to move it to row or column row, and the column is going to be start position and 0, and the row is going to be start position 1. So copy those and put them in there. And then finally, the tile status is going to be tile status start. So put that in there. And then once we've done this, we can get rid of all this, because that is that stuff. We just copy pasted this. So now it's a little bit sleeker in terms of the way it works. Nice. Well, at the same time, we can do the same thing. I'm just going to copy paste this part. I'm going to put that down here. And this time, instead of starship, it is a target. And instead of start position, it is the goal position. And instead of start, it is goal. And now we can get rid of all of this except for, don't get rid of the compute tile cost, please, at the bottom. Leave that alone, right? So get rid of all this. And so now, other than the compute tile costs, the moving the goal or the target is the exact same as the other one. It looks very nice. And it's much slimmed down compared to what we had before. Now, we need to check this. So what we're going to do for now is let's run it. Again, you're not going to see at this point any of the impassable tiles because we removed them. But we're going to get back to that in a second. For now, I should be able to move my starship and my target around the grid without any kind of errors. All right, so you can see here I could toggle this on, and if I want to move this around, we shouldn't see an error now with any of this stuff. It should just snap to grid, and it should realign. All this stuff should work as normal. So now we've added in that new move game object. Let's put this up on GitHub. So again, we're going to say git add dot git commit -m and say added move game object function. Okay, nice and easy, and it's not going to be too difficult for you to do this one. All right, awesome. So now that you've done this piece, let's go back to our playscene.h. We've done our move. We can move things around the grid, no problem. I want to continue making improvements, okay, to this thing. And I want you guys to drill down at this point. I think we're ready. Let's drill down below the heuristic. And I want to add in some tile mapping. I want to actually create a tile map. So tile map. Variables and functions, and we're going to make a new string. We're going to make a string-based tile map. And again, you may have done this in fundamentals with Alex. And oops. We're going to call this new one initialize tile map. Right, so that's one we're going to use, a new function. We're also going to have a function called build tile map. There's a difference between the two. We also want a couple of convenience functions. So convenience functions to update the tile map. Update the tile map. And those are going to be called a void m underscore update tile map, where we get a column and a row and the tile status. And just like we did up there for the other remove obstacle, we're going to create, and we'd also do the same thing for get tile. We're going to go a void m underscore update tile map, and this time we're going to take a GLM vec2 object called grid position and also tile status. So this way we have options. We can put in either column and row when we update the tile map or a grid position. Okay, so that's some new stuff, and let's add all those in. Okay, so let's do that. So I'm going to go to the top, and I'm going to go here, and I'm going to generate definitions by declarations. You can see these are the ones that I'm adding, and click finish, and it's going to add them in here at the bottom of my code. So initialize tile map is where we want to start. And this is, I'm going to give you this one because it's kind of tough to type it out. It takes a little bit of time to do, and so I'm going to give you what it looks like. What it is basically is a string representation of your grid. So here's what it's going to look like. I'm going to grab this part from my notes and paste it in. It's going to look like this. And I'm just going to give you this piece in the chat. So here it is. So take that part and put it inside of initialize tile map. So what is this? It's a string representation of what it looks like in on the screen, right? Where the dashes mean that they are unvisited. The I means an impassable tile. The S is the start tile, and the G is the goal tile. And this is kind of a map of what it looks like. I recommend doing something like this for assignment 2 for you guys, right? Where it's pretty good. Now, how do I build this out? Because one thing is to use something like this, and another thing is to actually build it. Well, we're going to need a double for loop for this. So we're going to say for I, and we're going to go, we'll call it row first. So we'll start off like we did before when we built our grid. We're going to say row is equal to config row num, this one. And then we'll do another for loop inside, so a double for loop, where we go, this is going to be column. Column is going to be config and then column num. All right, so that's kind of our double for loop that we're doing here. Okay. Now this is where the fun starts. We're going to say, well, okay, I'm going to look at this, the tile map. I'm going to look at it. I'm going to say if m underscore tile map, if, and this is, we're going to use that same funky syntax we used before, which is row multiplied by config, and then column number. We're just using column number, doesn't matter which one, plus the column. This is going to basically index the tile map, which is 300 characters long, as if it's a two-dimensional array. That's what we're doing here. So we're just going to replace this thing the way it is. And we're going to say if the tile map at that particular location is equal to an impassable tile, right? If that's what it is, then what do I want to do? M underscore add object to grid. And I'm going to add in what? I'm going to add in M underscore P obstacles. And again, I'm going to use that same funky syntax, which is this whole thing right here. I'm just going to copy this part inside here, right? I'm going to put it inside of here. So I'm still going to access that same area, that, kind of impassable object. I'm going to use that one, right? And then where is it going to go? Column and row, right? Followed by a tile status that is impassable. There we go. So that's what it's going to do. It's going to basically like loop through this entire thing, look for an I, and if it's an I, it's going to create a new obstacle in that location. Okay, this is a great, we should be able to try this out now, where we initialize our map, right? And we can go do that inside of our start method. So save, let's go leave this the way it is for now, and let's go into start, and let's see what that looks like. So back to start. And you can see we have a grid here, but we can actually instantiate the map as well. So we can say something like, okay, so M underscore, and then we'll say initialize tile map, right? And then M underscore build tile map. And then that should give us, for now, that should give us, you know, the tile map is what we want. Now, I recommend doing this after the grid. So first we build a grid, then we do the tile map, because then it won't know how to get stuff done. So just move this from here, please, and move it here. Okay. But we also need to do something else in here. We also should build our obstacles. So before we build a grid, m_build obstacles, that is something we should do in our start as well. All right, so we build our obstacles. We have an offset here, but we don't need it anymore. Let's get rid of the offset. I was always complaining about it anyway. That's gone, right? And in fact, even in the GUI function, we can get rid of this offset because we got rid of it. Because now we're not even using an offset here. We can get rid of the offset here in the GUI function too. So get rid of that. Wonderful. All right, good. And so we initialize the tile map, build the tile map, and then add in, we can actually add it in different order. We can say, I want to add in my starship first, and then my target. But you're going to see that even this we can do with our tile map in a second. Let's try just like this right now. So the start method only has build obstacles. We build a grid. We set the heuristic. We initialize the tile map, and then we build the tile map out. Let's run this thing and see what we get. Going to take a second, and there it is. And so this was generated by my little string map, right? So if I go back to that string map, this part, that's what it generated. So if I add something like, I don't know, in the left corner, if I add another I in there, let's try it out. And if I just press play again, then instantly I have an other impassable object wherever I put this thing I want. And there it is. That's how fast it is. This is a pretty nifty way of adding in objects. Just make sure you have enough to fill in the blanks, if you will. Okay. Well, we don't have to stop there. We don't have to just put impassable objects. We can put in other objects too. Let's copy paste this one. So I'll copy this one. And what if I'm reading the map, this map up here, and well, what if it's an S? If it's an S, that means it's the start. And that means if it's the start, then we're going to add in a starship. So we can do that. We can say replace all of this with m_p starship. And then it's going to be a column row is where we're going to put it, whatever the column row of the starship is up here. And we're going to change this to start. Right? And let's do another one. Let's take it one step further. What about if it's not the starship? What about if it's the goal? If it's the goal, then we're going to replace this starship with a m_p target. Right? And instead of start, we're going to say goal. Okay, so that's pretty good. And let's take it one step further. What about if it's like some kind of common tile like this, which is kind of an unvisited tile? Well, we don't have an unvisited tile for this, but what we can do instead is do something like m_get tile. And we can say that column row, when we look there, we can set the tile status to tile status unvisited, so we can kind of reset that when we move things around. And that's pretty good. And that is when we build our tile map now, we're also building the start and the goal tile, which means, my friends, we don't need to do this in the start method. So if I go back to start, we don't need to do this stuff anymore. We can get rid of it. We can get rid of this as well because their tile map is doing that for us. And let's just move the compute tile costs out of here for now and put it just here. Okay. Just a reorganization. And if I run it, you're going to see that you're going to have the exact same thing you had before, but just with the tile map, which is pretty cool. And you can see that. We can still move it around, right? Except take a look. It doesn't clobber the tile anymore, right? It doesn't do that because it just ignores the impassable tile. We're going to move around the impassable tiles differently, and I'm going to show you how to do that in a second. All right, let's put this up. So we just kind of made a tile map. Let's put this up on GitHub. One thing to note, though, in the tile map is we want to, whenever we move around our object, we want to record it. So before we do that, one more thing to do in the update method. So let's go just teleport to the update method. So where it says, you know, we have a couple of things we haven't fixed up. The update tile map. Let's go there. Okay. Update tile map, and these two things, before we do that, we want to kind of update the actual tile map, the string. When we move things around, I want to update the tile map to keep track of what I've done, right? So we can do that. We can make a switch case, and we can switch by status. And we can say that, well, what if I want to, the status that I want to pass in is unvisited? Well, if it's the unvisited tile that I want to add in, then what do I want to do? I want to say that m underscore tile map. This is when I'm actually changing the string tile map. I'm going to use that same syntax, this part right here, this row column syntax, right? So I'm going to put that in there. And I'm going to say that that is equal to, if it's unvisited, it's going to equal to dash, right? So it's going to be the other way around. If I change something in the tile map, and I change it to if my tile status that I kind of change it to is unvisited, then also change it in this thing, update this thing. So whatever I want to, when I update the tile map, I can do that the other way around. It's not just one way. So let's just update these to const, because we're not going to modify those. And I can do other ones. I can say, what about if it wasn't this one, but I have an open tile? What if I want to specifically say that a tile is open? I can test for this, and I can change this to O. What about if I want to say that a tile is closed? I can do that. We probably don't have a case for that right now, but I could say, let's add some closed tiles. I could do that, right? And what about if I want to say that the tile is a goal tile? Right, then I could say that that is the G. And what about if I want to say the tile is a start tile? Then I can update the tile map with an S. And the other one we have two more. One of them could be a impassable tile, right? And then we would update that to I. And then finally we have a new thing that we've made. Remember, in the tile status, we also added in path. I added that in for you. So I want to use the path status. When we find the path, I want to highlight it on the map. So again, I can go here and say if it's a path, then add P to the map. So that means on the map itself, right? On this map itself, you're going to see P light up in here when we find the path. It's going to kind of show the path. All right, great. So this is the update tile map. But we can also use a pass-through where we say something like, what if I want to pass in the grid position instead of column row? Or I can do the same work. So I can say m underscore update tile map, and we pass in static cast of type int, which is the grid position dot x, and we also want a static cast of type int, which is the grid position dot y. Okay, and then we pass along the status. We pass it through. Like so, which means I can make these two const. Okay. So these are little utility functions to update the tile map when I make changes. If I move something around, I can update the tile map. Well, that's wonderful. We have something to move things around, don't we? We have the move function. Okay. Well, let's fix that. So back up to the move function. So that's the move game object. We can add updates when we move an object so that the tile map also updates, which is kind of interesting to do, right? So I want to do that here as well. So where we kind of update that as well. So I want to make sure my notes are accurate, so I don't want to mislead you. There we go. So the way this would work is, okay, so I ignore it if it's impassable, and after, if it's not impassable, then I want to, here we go, here's the first update, m underscore update tile map, where I update the tile map with the object's grid position, and the tile status, which is going to be unvisited. So I'm changing the place that I'm coming from. Wherever I'm going, I'm updating the tile map so that it's unvisited. Okay, that's what it's going to be. So it's going to like change the tile map, the string tile map. So it kind of notes it's that we passed through. Okay, save. And then the other thing is down here, we're going to say that when we update this, no matter what we do, we still want to update the tile map to the status, whatever the status is, right? Now, this is something that's interesting because the only time we update the status on the map is when we're not inside of an impassable tile. So this should be in here too. So m underscore update tile map, where this time we're going to say column row, and we're going to pass in the status, whatever the status happens to be. Okay, here. So that is a neat way of keeping track of the tile map, which is something that we want to do, right? So when we move something, we also move something in the tile map. Okay, awesome. And let's just run it to make sure it's not broken. We didn't break anything, and we did. Okay, so that's grid position is not a member of Starship. Where do we put that? And grid position is not a member of targets. Okay, that is really weird. And that's in template line 77. Okay, let's see where that is. Line 77, m underscore b object. Make sure that I've done it properly. And update tile status visited object grid position. Oh, it's get grid position. Ha ha ha. I'll be okay. There's no code hinting when it comes to these little templates. So, all right, let's run this again. And that's what I'm saying. I always run it to make sure that I didn't break something because you never know. All right, it's working and we're pretty good to go. We can move this thing around and there's no side effects. And we can move this around and it doesn't break right now. This is good. All right, let's put this up on GitHub again. So again, going back to this, and we're just going to say, so if I do a git log, if you forget the last thing that you did, the last thing I did was I added a move game object function. What I want to do now is I want to say git add dot git commit minus m, and I'll say added tile map, right? And then git push. So I added the tile map in there. So that's very helpful. I find that students a lot of times like to have the ability to add in a tile map here. This is hard coded inside of our file, but you can always load this from a file as well. And I'm going to show you something that you can do to make this even nicer in a few minutes. Okay. Next, what other things are we going to do to change stuff before we do pathfinding? Pathfinding we haven't touched yet, but we're just doing this kind of stuff first. All right, so now I think we're kind of ready for the pathfinding part. And we have our obstacles, we have our find shortest path, and down here we had some suggestions on some pathfinding. And I think what I want to do is I want to put all of this, just from an order perspective, I want to put all of this before my shortest path and all this kind of stuff. Okay, so we're going to call this a collections, that's what it's going to be, collections, as well as variables and maybe functions for pathfinding, okay? And we said that maybe we'd use a vector or something else. I'm not going to use a closed list anymore. That's gone. I'm not going to make it my open list for this one. Instead of my open list, what I want to do is I want to have my priority queue. In order for me to support the priority queue, I need to make some inclusions here. Let's make a couple more inclusions. So I'm going to include queue. I'm also going to include my new tile comparator function file that I made, right, with you guys, these two. And then down over here, instead of an open list being a vector, let's make it a priority queue. So I'm just going to change this. And we'll say that this is a priority queue. And priority queues have up to 3 different parameters, right? One is the type. Another one is the vector. And then the third one is the comparator. And that basically sets up our open list, right? And remember what our open list is. It's a list that is visited but not expanded. So visited but not expanded list of tiles. Okay, that's what it is. And for our path, I'm going to use a standard list, which is a linked list. That's what spoke to me when I was doing this. We're going to call it path list, right? And I'm also going to have a Boolean called m_path_found, which we're going to set by default to false. So the path's not found initially. For my functions, these are shortest path and other kind of functions. We're just going to call these pathfinding functions. So pathfinding functions, right? For these ones, what I want to do is I want to add in the find shortest path. I also want to build my path list, void m_build path list. That's a new one. So we're going to have to add that in manually. Let's add that in now. So just go here and generate definition, build path list. We're going to come back to this, right? So find shortest path, build path list, display path list, right? This is kind of something cool. Reset pathfinding and reset simulation. Those are all the ones we want to use. Okay, right here. Okay. So let's start getting into fixing this up. So again, this is my priority queue. Remember, what my priority queue is going to be like is a minimum heap in C++, which is going to allow me to organize my successors in priority order from the minimum number upwards. An ascending order is what we're going to do. Okay, that's what my priority queue is going to do. Okay, so let's go back into this and start figuring this stuff out. And the first thing that I want to work with is the find shortest path. Now, find shortest path is like the meat and bones of why we're here. This is going to be your A-star pathfinding algorithm that you're going to need for your assignment too. Okay, so so how does this work? And what I want to tell you is what I did with this stuff is I literally followed a pseudocode, right, for it. And I was hoping that some of you are ready with that too. I know I gave you guys a chance to do it. Did anyone else have a chance to kind of, try and do their own version of A-star? Again, it would have been nice for you guys to try, because if you did your own version of A-star, then we could have a conversation. Roger said tried but failed. Okay, let's try it out. Let's see what this is going to look like. So remember, the first thing about when we do our shortest path, first part about it is we're going to say m_get tile. And we're going to use m_p starship, and we're going to say get grid position, and we're going to set the tile status, set the tile parent to null pointer. Okay, remember that we're going to use this new tile parent that I added into your tile.h. Tile.h, we added in a tile parent. And the tile parent is a pointer to the previous tile in the path. So the previous tile in the path. Okay, that's what this is. So first we'll set the starships, because the starship is the start. It should not have a tile parent, so it should be set to null pointer. I'm just setting it here for sure. Next, m_p open list. This is where we actually add the open list for the first time. We're going to push onto the priority queue an m_get tile, and we're going to use m_p starship, and we want to get grid position that we want to push on. So this tile is the first tile we're pushing onto the list. So it's not the starship, but the tile that the starship is sitting on top of that we're pushing to the open list. Remember, we have normally two lists, an open list and a closed list. But here we don't need to have a closed list because we're going to mark tiles as closed. That's what we're going to do. But the open list is important because it's going to keep track of our path in some ways. Next, we're going to have a little Boolean local, which is going to be called goal found. And this is going to be our sentinel variable, so we can kind of exit the loop when we find the goal. Okay, goal found. Now our while loop. And this is kind of like that while loop where we say if m_p open list is not empty, if it's not empty, if there's still stuff in the open list, and if this is my little hack, my goal, not goal found, we haven't found the goal and the list is empty, then loop forever, okay? And inside this loop, this is where we do all the fun stuff. So we're going to say const auto. We're going to have a current node. The current node is going to be equal to the top of the open list, m underscore p open list, and we're going to say dot top. Top means because it's a queue, it's going to be kind of like the front of the open list. But this is the tile with the lowest f, which means distance, right? And this is the distance that we are the tile with the lowest distance estimate, right? And that's what it is. What is the tile? Which one of these things? So instead of us doing a right winding, where I'm going to say, like, let's look at the top tile, the right tile, the bottom tile, the left neighbor. Let's look at all these different successors. Instead of doing that, we're using a priority queue to do that for us. The priority queue is going to basically sort the things in the lowest order. Nice. So now that I have that, that's the current tile. That's the lowest one. Let's put that out. So standard C out. So we'll say current node. And we're going to get grid position.x followed by some kind of current node get grid position.y. And this is just going to show this in the console. Okay. Next, what we're going to do is, and this is part of the pseudocode, is we're going to say m underscore p open list, and we're going to pop. And you're going to be like, wait, we just added it in up here. You're right. I pushed it up here, and I'm popping it down there. But remember, this while loop is going to set the current node to the lowest, the one that has the lowest value every single time it loops. So in the first case, yeah, it's like we pushed it and now we're popping it. Pushing means we're pushing it in the front, and popping it means we're popping it out of the front. Okay, that's what this means. Okay, good. So then after we pop it, we're going to say that the current node, and the current node is, we're going to set the tile status to tile status.close, because guess what? If we're at the current node and we're popping it off the open list, we're adding it to the closed list. Now, in our case, there is no closed list. What we're doing is we're just marking it as closed. Knox says, it has to be const for current auto? Const auto? Yeah, because we're not changing it. We're not changing it. Okay. Next, now this is where the fun starts. We're going to do a for each loop. Okay, for each loop. For each loop of our current node. And I've added a get neighbor tiles, get neighbor tiles function available, right? Let me show you where that is in the new tile that I gave you. And this is for every neighbor, right, in neighbor tiles. That's what this is. And how do I get neighbor tiles? Because before we only had like get one neighbor tile, right, as an example. Well, I modified your tile.h, like I said. So tile.h actually has a get neighbor tiles, and it gets a reference to your neighbor tiles array. So if you look here, get neighbor tiles returns the neighbors array, or the neighbors vector. That's what it does. Okay. So now, because we can get that, we get all the neighbor tiles that belong to that single current tile, what that is, right? And now we start doing our checking. We want to ignore these. And the tiles we want to ignore are if my neighbor, right, is equal to null pointer. So somehow if it's equal to like some kind of an edge tile. If it's an edge tile, we want to ignore it, right? Or here's the other case. If my neighbor, right, get tile status, if it's equal to the impassable tile. If it's an impassable tile, like a mine or something else, we want to show a wall, we want to ignore that too. We don't want to use this in our pathfinding. We want to ignore walls, right? Okay, so we're not going to go through walls. And then we're going to just put continue. And what continue does is it goes back to the top. That's what it does, okay? That's we want to ignore these things. Next, what about if, here's another case. Case number 2, if our neighbor, right? My neighbor tile that I'm looking at is get tile status. If this tile status is the goal tile, right? What if it's the goal tile? Well, if the neighbor is a goal, we're done. We don't want to continue. So again, we would say that goal found is equal to true, right? We're going to say neighbor, and we're going to say set the tile parent. We're going to set the tile parent to our current node. So what that means is when it comes to pathfinding, we're going to set up a list or a linked list of tiles, and we're going to say that the previous node is this parent's node, or the parent's path node. It's almost like the previous node to this one is the tile parent. So I can kind of link back and back and back and work my way backwards from the first start tile all the way to the goal tile. That's what I'm doing. All right, so neighbor, tile parent is the current node, whatever that current node is. Awesome. Excellent. Next, we want to print that out. So let's just use this cout example up here. Copy paste. Except we'll make some changes. We'll say that we won't say goal position. We'll say neighbor. We want to output the neighbor position. That's what we want to find. And we want to also say something like, well, goal found, right? And goal found at this position. There's the grid position. So neighbor X and Y, whatever that X and Y position is. Then what we want to do is we want to update the path list, m_p path list. We want to push front. This is why we're using a linked list, because we can push to the front or the back, right? And we're going to push the front the neighbor. Now you could have also, instead of a linked list here, that I used a list. Remember, I said that in my data structures, I decided to use a list. But you can certainly use a stack here instead. That's also very good. Okay. Awesome. So okay, we're good. We said everything is great, and that's awesome. That's what we've done there. Also, we want to break out. So we're going to say, let's break out of this little loop. So break out of the for loop. And then if we broke out of the for loop, it's going to detect that the open list, either the open list is empty and the goal is not found. Well, guess what? We found the goal, so it's going to break us out of the while loop too. Okay? That's what this does. So this is the second case where we find the goal right away. Here's a third case. If my neighbor, right, the get tile status, if the tile status is equal to the unvisited, if we've never been there before, well, that's a great place to put it up. You know, can make it part of the open list. So we're going to say neighbor, and we're going to say that let's set the tile parent to the current node, just like we've done before. And we're also going to say neighbor set tile status to open. Okay, we're going to put it on the open list. And we're also going to say m_p open list dot push, and we're going to push the neighbor to this list. So we're marking it in the map, but we're also putting it on the list. And marking it and putting it are two different ways of kind of recording what's happening. And my friends, that's pathfinding. That's it. This while loop and the for loop, and all this piece right here is a star. That's all it is. Okay, now there's ways of even shortening this too, but one step at a time. I've got extra lines here for printing stuff out, which we don't need, right? And I've also got an extra little thing here. We probably don't need this, but I'm just putting it out there so you can do all this. Next. Well, now that we found the goal, if we found the goal, this is outside of the while loop. It's still in the same function. We're going to say if goal found, right? Then what? Then we're going to say m_path found. Path found is equal to true, right? We could have put that in there too. If you really wanted to, we could have put this here. And we could have used path found instead of goal found, but it's okay. m_build path list. We want to build the path list, right? And we're also going to display the path list. Display path list. This is where we asked you to display the path list out to the system. what about if you didn't find the goal? What if there's no goal? Like it's, it's, it's blocked or something like that, right? Then it's else. Else, there's no goal. Well, we want to color the console to make it red to show that there's no path found, right? In order for us to do that, there's a really smart way of doing it. We can use WinAPI. So at the top, let's add in a reference to WinAPI. And the way to do that is up here, we can say include, and then windows.h. Okay, windows.h. Windows.h is WinAPI. And that allows us to control the console. Let's go back to where we were, way back down here, right? And what we want to do here with this one, right, is here's a couple things. So first, let's change the console. Const auto handle, we'll call it, which is going to be get the standard handle. That's part of the WinAPI. And we're going to use standard output handle, which is going to get a reference to the console, right? Then we're going to set the console text attribute, and I want to use that handle, which is the reference to the console, and I want to use the color that I want to use, which is 4, and this means red. That's what it's going to mean. The text red text. Okay, I'm changing the text to red. All right, and then I'm going to say standard cout, and we're going to say no path found. Oh no path found, kind of thing. And then standard and line. So that's going to be cool. And then what we want to do is we're going to copy this part, and we want to make it so that it goes back to white text. We want to set the text back to white. So this is white text. And 4 means red, and 15 is white. That's how it goes. Okay, that's just WinAPI, a reference to that. And that is, so if we found the goal, we mark path as true as found, we build the path list and display it in the console. If it's not found, we say, oops, no path is found in red, and then nothing happens. We don't find a path, okay? So that is your entire A-star pathfinding piece, right? But now we need to continue with build path list. We want to be able to follow the path list, and this is part of what you need to do for this lab, for this week. So we're going to say while, here's the while loop, m_p path list dot front. This is kind of neat. Remember, we can look at the front and the back for a linked list. We can say that get tile parent, right? If it's not equal to null pointer, so if we're not at the front of the, like we're not at the start again, then what do I want to do? m_p path list. And this is interesting. I want to push to the front, right, what we have in the front already, m_p path list, and we want to look at the front, but we want to use the get the tile parent from the object that we already have in the front, and we want to push that in front of that one. And it's going to be almost like a recursive call where we keep on pushing the parent from the current tile to the front. And then we look at the new front, and we take a look at that parent and push that to the front until we don't have any parent left, until we're at the beginning of the list. So that is build path list in completion, right? How about display path list? So display path list is the other one we want to do, right? And display path list is similar to build path list, but we're going to use let's talk about this for a second, standard cout, and we're going to go, so total path length is, and we want to kind of add in m_p path list dot size -1 is the path length. Whatever the size of the path list is, -1, that's the path length. And then we're going to do a standard cout where the path list is, and we want to kind of put this in quotations, Tom. There we go. Oops. The path list is, and then we're going to make a new break. And let's put a little separator. We're going to say one of these. Wonderful. And then we're going to make a little for loop, right? For each loop, actually, where it's m underscore p path list. And this one will be the, for every node in the path list, we'll make a const auto node. And we'll say that node set the tile status, right? Set the tile status to a tile status.path. This is the new thing that I added in with you guys. So we're actually going to mark it on the in the debug view anyway, which is pretty cool, right? That's what this is going to do. And then after we mark it, we're going to output it. So again, I'm just going to go back up here where we have this example of an output, goal found out, or whatever it's going to be. But we have it actually up here with the grid position. I'm just going to grab all of this. And I'm just going to put this back down here for displaying it. And we're going to say instead of current node, this is going to be node. And this is going to output we're going to display the path list to the console. Okay, so here we're going to display it, make a function const. Now, if you really want to play around, there's some things you can do here to make it nicer. Because we're already playing with color, we already played with color up here, we could make this color green somehow, right? So if you want to make this like the total path length is green and all that kind of stuff, you can do that. We'll do that more in IMGUI anyway, but this is what we want to kind of do. A couple more. Let's do the reset pathfinding. So how do we reset pathfinding then? Well, now that we have our path list, what we want to do is remove it. So let's remove all nodes from the open list. We want to do open list. And the way to do that is we're going to do a while loop. While m underscore p open list is not empty, okay? If it's not empty, there's still nodes to put in there. Then let's m underscore p open list dot pop. So pop everything off the list and get rid of it. It's going to go to the bit bucket in the sky this way. And similarly, we're just going to kind of copy paste this. Similarly, we want to remove all nodes from the path list as well. So we're going to say the path list, m underscore p path list, right? If it's not empty, then m underscore p path list pop. Pop. And we want to pop front, actually, is what it is, pop front. So we want to move from whatever it's in front of the path list, we want to get rid of that too. So this is the first thing. When we reset pathfinding, we do all this. As well as we want to make sure that the path is not found. So reset path found boolean, right? So that's going to be m underscore path found is equal to false. So we didn't find the path because we're resetting it. And we also want to mark all the tiles in the grid as unvisited. Okay, unvisited. The way to do that is we're going to do a for each loop for every m underscore p grid. For every tile in the grid, we'll say a const auto tile. For every tile in the grid, we want to say that if my tile gets tile status, if my tile status is equal to tile status open, right? Or we'll put it on the next line, or tile is get tile status closed. That's also an option. Or if my tile get tile status is equal to path, if it's one of those, right, then we want to reset it to tile set tile status to unvisited. So we want to set all that to unvisited again, okay? So that's what reset pathfinding does. It kind of sets all that up. Then we want to set our starship and our target to our start and goal as a status. So we're going to say m underscore get tile. We may not need to do this later on. M underscore p starship. We want to get the grid position, and we want to use that grid position to set the tile status to start. Tile status start. And similarly, we want to use the target here, m underscore p target, to set the tile status to goal. All right, so that's kind of how we're doing it. And so that this is basically resets all the stuff that we just put in. All right, this is resetting pathfinding. How do we reset the simulation? Okay, and again, I'm putting all these together first because I want to get all these things done, and then we'll move into actually trying it. Okay. How do we reset the simulation? Well, the reset the simulation works like this. We're going to m underscore remove all obstacles. Remember what this does. If I go to definition, remove all obstacles loops through each of the obstacles in the obstacles list, removes children, and clears the array. Okay, that's what it does. And then after it does that, we want to build them back up. M underscore build obstacles. Okay, we want to do that. We want to also remove child, the M underscore P starship, get rid of all them. And we also want to remove child, the M underscore target, remove that. And then finally, we want to m underscore initialize tile map again, the way it was before. If I go back to the tile map, that means we want to make it go back to this, that hard-coded thing we had last time. So we're really resetting. We're basically saying, you know, that is kind of how we're going to do we're initializing our tile map. Then we got to build the tile map, m underscore build tile map. So we're going to instantiate everything, right? And we're also going to m underscore p or m underscore compute tile costs with a target and the starship in place, and finally reset the pathfinding. So everything else is reset, okay, as a result. So just in case you did everything, we reset it, and we're back to normal. Now again, these are an order that I put together, but we may want to move things around a little bit here. All right, so that is all of the functions. They're all complete now. And let's test it. So let's save all. And let's go back to our start method. And what we want to do is temporarily, let's just put in find shortest path in here. We're going to say m underscore find shortest path, right? And this will, if you look at what it'll do, just to go over it again, go to definition. It will use a star to find the shortest path. If it's found, it will build the path list and display it in the console. If it's not found, it'll display no path found. Okay, that's what it will do. All right, let's try this out and see what happens. So save and go. And if everything goes well, then finishes building. Okay, wonderful. If I go here, notice that I already found the path list. Look at it, it's right here. It says the path length is 25, and this is the path list 2, 3, 3, 3, 4, 3. All this path. This is the path list right here, right? So let's take a look and see what we can see in the toggle grid. You should see something that looks like this, which is awesome. This is what I wanted to give you guys, right? So yellow means it's open. The P means that's the path, right? C is the closed list. These are the impassable tiles, and we're pretty good, right? And what I want to do is I want to make some buttons so that we can do all of this up here without doing it manually like we just did, okay? Okay, let's put this up on GitHub. I think this is a good place to do that. So again, I'm just going to go and git add dot, git commit -m. Say added a star functions. Git push. Questions around this so far? I know this is a lot, but I mean, I literally all I did was follow a pseudocode, which means this little pseudocode in here that's part of our that I kind of shared with you this morning, right? If you look through this, it actually has the pseudocode for A star. Initialize the open list, initialize the closed list. We don't have a closed list. We have we're marking things as closed. While it says put the starting node in the open, we did that, and you can leave it its f at 0. We didn't need to do that because whenever it says calculate what the f is, we did that because we cache all the f values because we do all the computing the tile cost ahead of time. All of our tiles are smart tiles, and so it's a lot of work is done for us before we even get here. Then it says while the open list is not empty, we did that, or the goal is not found. I put that in there as an extra thing. Find the node with the least f. That's the node at the top of the priority queue, right? And then what we want to do is we pop that off the list and find its successors. Now we're not using 8 successors, we're only using 4, right? And then we can continue. For each successor, there's the for each loop. If the successor is the goal, stop, right? If a node with the same position as the successor is in the open list, which has a lower f than the successor, skip the successor. We don't have to do this part because what we're doing is we already have a priority queue to take care of this. So this is something we can avoid. If the node with the same position as the successor is in the closed list, well then ignore. We did that already. Otherwise, push Q onto the closed list and then end the while loop, which we kind of did in this fashion. So pretty much I follow this exact thing when I made my A-star pathfinding algorithm. That's what we did. Okay, so going back to this then, now it's just a matter of adding more IMGUI functionality. Let's do that next. So again, I'm going to go into our GUI function. And let's really fix this up now and make it look nice. Okay, this is the next part. And I'm sorry my voice is dying, but I'm going to try my best to be understandable. All right, so in the GUI function, like right now, we have a toggle grid, and it'd be nice if we could see the grid. Like, imagine if we can see the grid and modify it in real time. I want to be able to do that in the GUI function. So that way we can actually have different cases for looking at what the grid looks like. Let's do that here by adding in another separator. So in the separator, in between these two things, I'm going to let's add tile map properties here. And we're going to say if I am GUI, and we're going to use a collapsible header, which is kind of like a little collapsible area, which we're going to call tile map. And inside there, if I click into it, I'm going to have a static tar pointer called tile underscore map, a local variable that I'm going to use, that I'm going to initialize with 300 elements, okay? And then I'm going to say for I is equal to until m underscore tile map dot length, right? Tile map dot length, right? I want to loop through each of the elements in the tile map, like the actual string map. That's what this is. The tile map is a string map that we used earlier, right? And I'm going to say that tile map I, this is the local tile map that we have. Tile map I is equal to a new character of type I. In other words, I'm copying the map, the thing from my actual tile map, right? I'm making a brand new one, and I'm instantiating an object of type empty character, and I'm assigning it to my tile map. And then I'm going to use another thing, sprintf. Sprintf is like a string formatting function. And what I can do is I can take the tile underscore map, the local tile map that I have here, and I'm going to pass in %c plus %d. That's the name that's going to be my button that I'm going to make. I'm going to make a bunch of buttons. And I'm going to take the name from my tile map, the actual tile map, and that's going to be C, the character from my tile map at that location, right? Which is going to be like an I or a dash or a G or an S or whatever it is that I want to put in there. And then I'm going to also make it a specific button name, because each button in IMGUI has to have a unique name. It can't be the same. It can't be dash, 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 dash. Otherwise it won't work. We have to give it underlying. We have to make it its own, another name for itself. So I gave it a space so we don't see it, and a number. Okay, that's what it is. So that's the formatted array. So this is a formatted string, is what we made. And now we're going to say if I %20, right, is not equal to 0. So if I %20 is not equal to 0, which means it's not the end of the row, then what I want to do is I want to put all these buttons I want to make, almost like little buttons. I'm going to say I am GUI, same line, only if it's the, as long as it's not the end of the row, I'm going to add a bunch of buttons. What I'm going to do is I'm just going to draw this out for you so you see what my intention is. I want to make it so that in I am GUI, I'm going to have literally like little buttons like this, all right? And each little button is going to be the tile in the map that you physically see on the left-hand side. Each of these buttons is going to have a symbol, an I, a dash, whatever it's going to be here. Then I can press the button, and if I press the button, I can change it from an unvisited tile to an impassable tile, which is kind of really cool. Okay. So that's my intention. Let's keep going. So that's what this is. Put it on the same line is what this is saying. Okay, good. Otherwise, if it's not the end of the row. If it is the end of the row, it's okay. Go to the next line. Now I'm going to look at my tile map, the actual tile map string. That's what this is. And I'm going to say, okay, if my tile map, as an example, is equal to is the start, well, you know what? I want to color my button. And the way I can color my button is I can use I am GUI, and I'm going to say that we're going to push the style color, push style color. I am GUI can change the button color if I want. So it's I am GUI color, right, button. And it's going to be an IM vec4, right? And the IM vec4 that I'm going to use is a special number pattern, 0.360F. I'm going to talk about this in a second. 0.721F and 0.360F, as well as 1.0F. And you're going to be saying something like, Tom, where the heck did you get this thing? These are actually Bootstrap colors, which is the primary Bootstrap color. I use Bootstrap to get all these color values. And instead of you having to going to do this manually by typing all this out, I'm just going to copy paste here just to make it easy. So these are the other ones. Okay, so if I'm going to do the G is going to be the gold tile. That's going to be Bootstrap success, Bootstrap success, which is going to be a green color. This will be a blue color, right? And this one here will be a, if it's other than that, as an example, it will be, sorry, S is start, green, red. It's going to be this will be a red color. So this will be Bootstrap warning. This will be a green color. Sorry. This will be a red color. I'll be okay. And this will be a blue color. Bootstrap primary, which is blue. Okay, so I want to just give you these. So I'm going to copy paste these into the chat, so you don't have to do that typing. But these are actual color values that I took from Bootstrap, Twitter Bootstrap, which gives me some nice colors that we can use in our map. Okay. Okay, so that colors the button. And what we're going to do then is say something like, well, if I am GUI button, if I click on the button is going to have a name, which is tile map I, the local tile map that we made, right? And it's going to have a color, a width, vec2, with a width that's 15 and 15. So what this is going to do is it's going to basically say the button itself is going to be 15 pixels by 15 pixels. All right, that's what I'm for every button in the. I'm going to make a bunch of buttons, one button for every tile in the grid. Okay, and then I'm going to say if m underscore tile map, the actual tile map, if the tile map is not equal to start, and the m underscore tile map is not equal to the goal, so both of those are true, right? Then I want to do something like this. Then it must be something else. If the tile map I, here's tile map I, is equal to, we're going to use the ternary operator here, m underscore tile map I, right? If it's equal to the unvisited tile. If it's an unvisited tile, then what I want to do is return, I want to switch it to an impassable tile if it's unvisited. Otherwise, if it's an impassable tile, I want to switch it to a visited tile, unvisited tile. Okay, so this is kind of like a toggle. So this toggles, you know, unvisited to impassable. So I can draw, I'll be able to draw on the map, right? And it'll physically switch it in my screen. That's what I want to do. All right, here. All right, cool. And then m underscore remove all obstacles. That's what I want to do. Remove them all. I want to build them back up. Build obstacles. And then I want to m underscore build the tile map back up. Build the tile map. And m underscore reset the pathfinding. Reset pathfinding. Okay. Now there is a thing here. All right. Because I've kind of done all of this. It's almost like I'm resetting the simulation. Almost. But I don't want to quite reset the simulation. The two things that we're missing is I haven't reset or haven't removed the start and the goal tiles. I haven't done this. And really, when I build the tile map, I reinstantiate them. And this is my glitch, I pretty much know. So let's put them in here. So just like we did, if I just quickly jump, save this, and if I quickly jump to the reset simulation, you can see I kind of did that here, where I built the obstacles and then we initialized the tile map. We don't want to reinitialize the tile map. We want to use the new tile map we're making in live. We do want to do this, all right, which is something I missed. Right? So down in here, I want to build my obstacles, right? And then I want to remove my starship and my target and then put them back. Because remember what build tile map does, go to definition, it actually puts back the start and the goal tile depending on where they are. That's what it does. It says, hey, wherever it is in the map, this map here that we keep track of, put them back is what it means, okay? Save. So that's what that does. Okay, cool. So that's what this function does here, right? And this is the end of the if statement. Now, at the end of the if statement, because we pushed a color style, we have to pop it back off. Otherwise, IamGUI will complain. IamGUI pop style color is what it is. Pop style color. And this will pop, we only have one style color we popped on, so we can only pop one off. If we had multiple style colors we popped on, we'd have to pop multiple ones off. We're only doing one at a time. All right, so that's what this does. Let's take a look and see how this works, because this is kind of neat, right? So save. And if I kind of run this thing, we haven't done any pathfinding yet. We haven't kind of removed pathfinding, but I want to show you what this kind of does. So if I go to IamGUI now, and if I go to here, you can see that in here I have a little tile map. And this is what it looks like. It's actually a physical representation of what this looks like. And I should be able to just literally just type in these things and draw whatever thing I want in here. So I can create almost like a little pathfinding algorithm here, okay? Also, there's some glitches. I mean, if I move things around here, it's gonna be weird. That's one thing that's gonna happen. So that's something that it's gonna trigger. But we're gonna get to this in a second, okay? Notice that it actually moved these things in the map as well, which is cool, right? All right, so that's what this did. That's the collapsible header tile map. And I want to give this to you because when you're writing your assignment 2, this will give you an opportunity to make other things, not just impassable tiles that are looking like mines and starships, but making whatever tile map an interesting map you're going to make for yourself, okay? Nice. So that's what this is. We're almost done, guys. Now. We did our heuristic, which is nice, but when we changed our heuristic, we don't just want to compute tile costs. No. What we also want to do is we want to check to see if there's pathfinding, if the path list is not empty. And if it is, let's reset it. Every time we change our heuristic, we should reset the path list. So we're going to say if not m underscore p path list dot empty. If it's not empty, then reset it. So reset pathfinding. That's what we want to do, this one, right? And we need to do this a couple places. We'll talk about that in a second. So that's the first thing. So in our heuristic, that's when this changes. And you know what? This would be nice to put in if we're moving things around too. Reset the pathfinding. If I'm moving things, reset pathfinding, right? So that means in our move function, let's copy paste this part. And if I go to the move function, which is this one, then it's kind of the same, right? I move, well, as soon as I move something, I want to reset my pathfinding. I don't want to be able to move and all of a sudden have issues. So I want to put that right at the bottom. So right at the bottom here, I'm going to say, you know what? Reset pathfinding, right? If it's not empty, reset pathfinding. We're going to do that for the move game object. That's what that's happening, right? So we want to do that. Back. All right, so now that we've reset pathfinding for 2 places, we want to start adding in some additional buttons in the UI function, right? So like it'd be nice if we have buttons to start the pathfinding off, and it'd be nice to stop pathfinding and all kinds of other stuff. Let's add those things in. All right, so that's something that we want to do, kind of here. So remember, we want a button. That's what we want to have, an I am GUI button that allows me to start pathfinding. We want a button that allows me to reset the path list, reset the simulation, a bunch of other stuff here. Let's add them in. So again, I want to add another separator. This is before we move stuff on the grid. Okay, so add a separator. And then what we want is a button. We're going to say if I am GUI button, and we're going to call this button find shortest path. This is the key one that you need for this lab. If I press the button, and if the path list is not empty, if I press the button, well, clear the path list. That's what I want to do. Redo it. Redo the path list. And then at the end, find shortest path. Okay, we want to do that. That's really the find shortest path button. There's nothing else to it, just this. But I want to add in the same line, if m underscore path found, okay? If the path is found, then what I want to say is I am GUI, same line, and the same line, let's add an I am GUI text colored text, which is the color of the text is going to be green. I am vec4 is their own color green. And that's the color, so that's green. And then we're going to say path found, right? And we're also going to indicate the length. The length is going to be %d, where we're going to kind of put in m underscore p path list dot size -1. Okay, so that is going to be actually imprinted whenever we do find shortest path. If we found the path, wonderful. Okay. Next, we want to reset the simulation, reset the pathfinding. Okay, so I'm going to kind of make another one of these ones, another separator, and I want another button. So I'm going to say if I am GUI button, here's button, and this button is going to be reset pathfinding. How does that work? Well, it's pretty simple. It's literally m underscore reset pathfinding. That's done, right? So that's how we can reset the pathfinding. But we also want to put on the same line, I am GUI, same line, right? We want to put in another button, if I am GUI button, and we're going to say that that is called reset simulation. That's the whole thing again. Reset everything, basically what this does. And we kind of have this function, but we need to be a little bit careful. In order for me to reset the simulation, I also want to reset where the starship and the target is in the grid when I move things around, in the little slider floats or slider ints. So in order for me to do that, I need to move these declarations here, the static start position and the static goal position. I want to move these up. So cut, and let's move them above, as an example, the reset pathfinding, but below the separator. So here. And these are kind of like position variables, which are static. So these are static position variables. So we're going to declare the start position up there, and we're also going to declare the goal position up there. Again, later on, we may move them somewhere else. if we're going to, if we had time. All right, so that's what those are. And the reason why we want to do that is because I'm just going to kind of take away some of this extra space. The reason why we want to do that is because inside the reset simulation, we also want to reset the place, the static positions in the slider. So the slider is updated as well, okay? Like the actual UI element. So we're going to say something like m_reset simulation. We have all that code already. We're done. But on top of that, we want the start position, the start position to be something different. So we're going to say, okay, start position, this one, start position 0, we're going to say is equal to a static cast int of m_p starship, right? And then get grid position dot x, and we're going to say copy paste. So this is just going to reset the sliders. That's what this thing does. Reset sliders, right? And this is the reset movement sliders. So this is the start position 1, which is the y, is we want to static cast y to the starship. And then we'll just copy paste both of these and we'll do goal position. So we'll say goal position. So that's what this is going to be. Goal position, this one. And goal position 0 and 1 is going to be the target, m_p target x and target y. And that's going to reset the sliders for where it's going to be. And my friends, that is it. So now all we have to do, last step, right after this, is let's clean up some spaces, okay? And we just have to take away that find shortest path in the start method. Let's do that. So back to start, and we have this temporary find shortest path. Let's get rid of it, right? We don't need that anymore. We're going to do that in IMGUI. And let's see if it all works. So play. And we can see the grid. Here's the grid. And if I go find shortest path, bam, it just shows me the shortest path right away. And if I was to change the tile map, take a look at this. If I change the tile map, instantly the path is reset. The pathfinding is reset. I can kind of make it so that it doesn't find any path. Let's say if I box you in, and if I go find shortest path, it's going to say no path found, and it's going to fill that area up with closed tiles, right? I can reset the simulation, puts everything back to normal, and then I can kind of do another thing. Let's say I want to make another enclosure so that there is this area all enclosed. If I find shortest path, that whole area is closed and there is no shortest path found. I can reset the simulation again, and I can add in more challenging paths for the Pathfinder algorithm, right? So I can say, okay, well, there's only one way out, and let's continue to make some interesting pathways. So something that looks like this, like a really interesting path, that's this. And I want to add some more blockages over here, right? So like there literally is a very slim way of getting around. Maybe even some additional path, kind of things there, and even some stuff here that is really problematic. Something like that can be caught in there. Let's see if our Pathfinder gets trapped right inside of different parts of our simulation, right? Let's just do one of these, right? So really difficult to find it, kind of thing. And let's see, can our pathfinding algorithm still find a path from here to there? Bam! And it does, instantly, right? Which is really cool. And the other thing that's really great is this. I can change from Manhattan to Euclidean. And as soon as I do that, I can click find shortest path, and it's a different path that it finds, but the same length. This is 51 units long. I change to Manhattan and click find shortest path, it's 53 units long. So actually Manhattan actually found a longer path than Euclidean. It's actually a different thing, right? Which is pretty cool. All right. So that's pretty good. If I move any of these things, this is where it broke earlier today. Let's see if it still breaks. I think I found my error, but if I move it around, you can see that I can move my stuff around and it doesn't break any of the things I made. And I can just still say find shortest path, and bam, it just does that, find shortest path, and it moves it here physically. And I can do the same thing with my my goal. I can move the goal over here, way over here. Maybe let's put it inside of a corner, like in here, right? And you can see that that is inside of there, and this is the start. And if I click, bam, find shortest path, it'll find the shortest path. It'll wind around and find it. And if I use Manhattan, it's 43 tiles. But if I use Euclidean, it's 43 tiles, same amount, right? So that's the way it works. And this is, my friend, the gift I wanted to give to you guys. I worked kind of hard on this one to make it work for you guys yesterday. And I think it completely works the way I wanted it to. Stuff that you can improve if you wanted to. You can make the impassable tiles darker. So instead of making it so that it's a blue color, you can make it so that it's a gray color. So you can see what it looks like here is kind of what it looks like here, right? And you can have a little bit of a tile map here. Where this is really great is you can check your level out. You can actually trial out, different level variants here altogether, where, you can kind of trial this out and then find shortest path, and you'll see what it does and how it kind of maps in the closed and open tiles, right, as it finds what it's looking for. So pretty cool. It doesn't get locked up. And even if we do lock it up, if I kind of close that off, so there's no other way to go through here, and let's say there's no other way to go through there, and let's say there is, I don't know, maybe something like we close it off completely down here. So maybe so it's not possible, like closed off, then it still works, right? It just kind of ignores this area down here. It doesn't get stuck, which is pretty cool. But if I completely close it off, I close it up here, so there's no path, then it'll say that. It'll say no path found, and it'll close off all this whole area because the starship is going to try and find a way around this whole area, and it can't. There's nothing it can do to figure things out, all right? That's great. So let's put this up on GitHub, and this is the final version of the code. Questions around this, please. Added IamGUI buttons and UI. Oh, actually, we'll just say IamGUI UI elements. UI elements. Oh, there we go. Andre says, catching up through YouTube. Any questions at all? Anyone else have any questions that they can go through? Roger, are you good? Did that fix you up the second half? Hopefully it did. All right, so just to end off for today, a couple things of note, just to go back to our schedule before we end off. A couple things. One, I will release assignment 3 and 4 later today, okay? Did it at first, but once I added the pathfinding button, it stopped showing the colors. That's weird. Okay, we'll come back to that in a second. So assignment 3 and 4 are going to be released today, and it's going to be basically, in the second half of semester. Remember that next week there is no class. We're not getting together next week. This Sunday, assignment 2 is due, as well as lab 5. Both of those two things are done. One is individual. The other one is a team that you have to get done. Okay, that's what's happening there. So please make sure you you have everything done on time. And communicate with me if you have any issues. I've given you as much as I can, right? One other thing is, for this lab, there is a component for students to add. Please make sure you add this component. We've talked about how to find the path. That's what this has done. But now I need you to move along the path. How would you do that? How would you move along the path, right? Well, remember, if I go back to my code, I have the path list. I literally have the path list for you. So if I go back to my playscene.h, I've given you the path list. This is a list of nodes that I can follow. If you think about this, I can step through each node. If I have another button, I need a button that basically says, kind of follow path or whatever it's going to be. And the follow path button, the easiest way to do it is if I was to run this thing, right, then I would just literally step forward, and I wouldn't turn the ship at first. I would just make it work, right? So one thing you can do is you can make it hop from one to the next in a time step, like almost like count some time. Take your time to go from one thing to the next thing. It's almost like wait a few frames, move, wait a few frames, move, wait a few frames. Almost like moving a piece on a board game. Okay. And then when you get to turn, like say, for example, if I find shortest path, it's going to go down this way. For now, just keep it pointing in the same direction, the first one, so that it moves down and hits moves from here to here. When you're moving the ship, make sure if you're following the path, you don't change the path itself. You don't change any of this stuff. You don't update the tile status. You don't do any of that stuff. You just move the actual game object around. That's what you're doing. Okay, that's some hints of what to do. Okay. Um, that's the first thing. Next step would be, okay, well, let's do the second iteration. I move, but when I get to here, I actually turn the ship, rotate the ship so it looks in this direction. So if I'm moving down, then the ship should rotate so it looks downward. And if I'm moving to the right, the ship should rotate so that it's pointing to the right. If I'm moving up, the ship should rotate so it points up, and so on. So that way it can keep moving along the path and it looks like it's marching along. That's what you should do. Okay? So that's how it should work. Okay? And that is for you to do, like I said, something that's part of your to-do right here. Okay? Okay. Any questions before we end for the day? I'm going to stop recording here, and then we're going to get back to any kind of questions for our local people. For the rest of you, thank you so much, and we'll see you in 2 weeks.